All right, let's talk about the weather. And I don't just mean any weather, I mean the really wild stuff we all seem to be seeing more and more of. Today, we're going to dig into the science that's connecting those dots back to climate change. So, how much harm can 1 degree of warming really do? I mean, you hear that number all the time, right? The planet's warming by a degree, maybe two. And it's so easy to think, so what? I won't even feel that. And, that's a fair enough question. But it kind of misses the real story. The answer? Well, it might just surprise you. Yeah, it can do this. 5 times. That's the increase in the number of climate-related disasters, the big stuff like major storms, floods, and insane heat waves, since the 1970s. A 5-fold increase. So yeah, something is definitely going on.
And this really gets to the heart of it. It's not about the average. A tiny shift in the average global temperature doesn't just mean your Tuesday is going to be a little bit warmer. No. What it really does is it loads the dice. It makes those really rare, really high-impact extreme weather events way, way more common. Okay, so what does loading the dice actually look like on the ground, in the real world? Let's take a quick tour of the extremes and see how this is all playing out.
The evidence, well, it's everywhere you look. We're seeing heat waves that are not just hotter, but they're lasting way longer. Storms are getting supercharged, packed with way more rain. Then you've got droughts, which get even worse because of all the heat. And of course, that just fuels more intense, more destructive wildfires. It's like this dangerous domino effect, where one thing just feeds right into the next.
And look, you don't have to take my word for it. This comes from the IPCC, which is basically the world's top authority on climate science. And they use the strongest language they possibly can here, virtually certain. In the world of science, that's about as close to a slam dunk as you can get. So when it comes to heat waves, the debate is over, the link is a done deal, it's a fact.
Now, when we talk about storms, it's not just one problem. It's really a triple threat. First, you've got more moisture. Warmer air can hold more water. Simple as that. Take Hurricane Harvey. It formed over super warm water and then just dumped an unbelievable 127 billion gallons of water. Second, all that warm ocean water, that's pure fuel. It's energy. And it's what's making major cyclones stronger and more frequent. And third, sea levels are higher now, so every storm surge gets a head start. We saw that with Hurricane Sandy. The higher sea level alone was responsible for over $8 billion in extra flood damage. Just incredible. Okay, let's zoom in on that second point for a second, the part about storms getting stronger. Because there's this really specific and frankly pretty scary phenomenon that scientists are keeping a very close eye on. It's a thing called rapid intensification. You'll see it called RI. And it's exactly what it sounds like. It's when a storm goes from being, just a regular storm to an absolute monster in the span of just a few hours. This makes forecasting an absolute nightmare. It can leave coastal communities with almost zero time to prepare for a major, major hit. And here's the kicker. This isn't just a one-off thing. It's not a fluke. Scientists have crunched decades of data, and they're seeing clear, unmistakable upward trends in this happening. So storms aren't just intensifying faster, they're doing it more often, and in more and more places around the globe. So the big question is, how do we know humans are behind this? Well, it's pretty clever, actually. Scientists compare what's actually happening in the real world, this big increase in rapid intensification, with what their models say should be happening, based only on natural cycles. And guess what? The two just don't line up. What we're seeing is happening way faster than nature alone can explain. It leaves a clear, a human fingerprint all over the data. This whole process of connecting the dots, of linking a specific storm or heat wave to the bigger picture of climate change, it actually has a name. It's a whole field of science. It's called event attribution. And the way it works is kind of mind-blowing. Scientists can essentially run simulations of a weather event, let's say a major heat wave, in 2 parallel universes. One is our world, the world we actually live in. The other is a what-if world, one without any of the climate change we've caused. And by comparing those two, they can calculate with pretty stunning accuracy exactly how much our actions loaded the dice for that event. And it's because of this incredible science that the IPCC can now make statements like this with just absolute confidence. This isn't a future prediction. It's not a theory. The latest report states it as a plain and simple fact. Human-induced climate change is already affecting extreme weather in every single region across the globe, period. And we're not just talking about 1 or 2 studies here. The body of evidence is just massive. At this point, researchers have done more than 500 of these event attribution studies. 500! Together, they create this incredibly detailed global map showing exactly how climate change is impacting our weather right here, right now. But listen, connecting the dots between climate change and a hurricane is really only half the story. To really get why this all matters so much, we have to talk about what happens when that extreme weather actually hits us, the people on the ground.
And this is a really critical distinction to make. There's the hazard, that's the physical event itself, the hurricane, the flood, the heat wave. But the disaster is what happens when that hazard slams into a vulnerable population. The storm itself doesn't pick and choose, but its impacts, oh, they absolutely do. And just look at how complex this is. The weather, the hazard, is just one piece of the puzzle. The actual outcome, whether it becomes a true disaster, is shaped by all these other things. Stuff like income, the quality of people's housing, whether they get early warnings, even how much they trust their local government. All these factors are what ultimately determine who gets hit the hardest. And that's why this attribution science is such a game changer. It's not just an academic exercise. By being able to scientifically link a specific disaster back to its roots in climate change, it provides the hard evidence needed for huge global policies. A perfect example is the Loss and Damage Fund, which is designed to help the most vulnerable countries, often the ones who did the least to cause the problem, cope with these devastating impacts. So think about where we are. We've moved past asking if climate change is fueling extreme weather. The science has now advanced to the point where we can ask how much it juiced a specific disaster. The science is solid, and that leaves us with a much tougher question. And this one isn't for the scientists. It's for all of us. Now that we can draw a straight line from cause to effect, what are we going to do about it?